All right, this first quiz was 5 questions. Let's talk about them. All right, so the periodic table question. In general, this had pretty high accuracy, so let's look at it. It says, which set of elements below is the most similar in chemical behavior? Well, what you should remember is that elements are similar in chemical behavior if they have the same number of valence electrons. When do they have the same number of valence electrons? When they are in the same group. Okay, so that means in group 1, in group 2, and then over here on this side of the periodic table, we would see those with 13 and 14 and 15 and 16 and 17 and 18. So what you needed to do was go step by step through this list and find 3 elements that were in the same group. So look, BE, BE, CA, CA, RA, RA. So there is our correct answer. Now, you may not have had this exact question, but you had one almost like it. All right, this one, let me just say, this one had low accuracy. All right, what you needed to use no matter which question, and there were a few versions of the question, which one you had, it required this formula, which is moles from the back of your reference table equals mass over gram formula mass. Okay. So everybody needed to have that, okay? And also in this one, both of these examples I have here use boron. Now, boron from the periodic table has an atomic mass of 10.81, which makes it, I could use that as it is if I really wanted to, but 10.8. Remember, not rounding to a whole number. All right, so let's see this first one up here. It contains this many grams, so that means grams goes on top, 0.0035 on the top, okay? Divided by gram formula mass. Well, that's what I just wrote here, 10.8. Now, when I do this, I know I am going to get a number smaller because I'm taking this number and I'm dividing it by 10, right? So my number is going to end up smaller. So this was 0.000324. That was the answer in moles, all right? Now, for this one, okay, you had to do the setup a little bit differently. So this one I know moles, so in place of moles I put 0.0035. Here I'm trying to find the mass, so that's grams, divided by, I still use the same gram formula mass. And remember what I told you, put it over 1, right? And then multiply. Right? Cross multiply. So this is just going to say grams equals, and I'm going to multiply this 0.0035 times 10.8, and I am going to get 0.0378. Okay? All right, this question, in general, this had a little bit of moderate accuracy. So the smallest particle of matter that can be identified as an element is called. Okay, so that means I take a sample of copper, right, and I make it smaller and smaller and smaller and smaller. How small can I make it and still have copper? Okay, if I have a sample of oxygen and I make the sample smaller and smaller and smaller, how small can I make it and it's still oxygen? Okay, that answer is an atom. Okay. Okay, so now this table I question, and quite honestly, this one had really low accuracy. All right, so what you needed to do, it literally said look at table I, so let's go look at table I. All right, so here we go. And it says, according to table I, which equation represents a change resulting in the greatest quantity of energy absorbed? So you had to know that absorbed means what? Endothermic. And then if you go all the way to the bottom of this table, I cut off the bottom so these I could read better, but it says a minus sign indicates exothermic. So if minus indicates exothermic, that means endo must be positive. So when I'm looking through this list, for example, oh, here's a positive number. Oh, here's a positive number. Oh, here's a positive number, right? So I'm going to be looking for one of those, and I need to go step by step through each one of these. So let me find this one for example, okay? So right here, that's this one right here. Okay, that's negative. Let's go to the next one that has C2H4. Oh, look, okay, seems like that's right. That's a positive. Let's keep going. All right, so this one right here, ooh, okay, that's positive. All right, let's look at this one. Ooh, okay, that's negative. All right, so I know automatically now I can cross these two out. They're wrong. But now I have two possible answers. But it says now greatest quantity. So let's look at these two numbers. Which one is a bigger, right? So that's going to be this one that absorbs the greatest energy. If it was releases greater, I'd have to pick this one right here because that releases more energy. I'm not concerned about the positive or negative, okay? The positive or negative just helps me determine exo versus endo. Then I'm going to look at the value of the number, okay? All right, so the percent composition question. Moderate accuracy, okay? This one, what you had to remember is the formula for percent composition. And you don't actually have to remember it. It is on the back of your reference table. It's mass of part over mass of whole, okay, times 100. All right, and when you do that, that's how you get your answer. All right, so gram formula mass is the whole thing. That's 164. That goes here, okay? And then the oxygen part, because it says percent by mass of oxygen. So now I got to figure out how much oxygen is in here. Well, 1 mole of oxygen is 16, but I have a subscript of 3 and then a coefficient, a subscript outside. So I have to do 3 times 2, which is 6. So 16 times 6, that's 96. So the part of oxygen is 96 out of those 164 grams. Now, looking at this, just mentally, half of 164 is about 80, right? So, and this is more than that. So my answer has to be more than 50%. Oh, look at that. Now I know my answer. There it is, okay? Regardless what you're gonna do, no matter if it's the same substance or not, you need gram formula mass as the whole, and then the part, you need the mass of that specific element or that part that you're being asked about, okay? Hope that helped a little bit.